This conference will now be recorded.
Hi everyone, welcome to the AWS training program. And as part of our AWS training, today we will be talking about PySpark. That means Spark with Python, or you can say Python with Spark. So Python we already know, like it's a programming language which can help you to do any type of programming. And nowadays it's in demand, like whichever project or whichever cloud you are working with, Python will be used very most frequently. So we'll be starting with Spark concept, like what exactly Spark is, and then how to achieve all those concepts, how to analyze the data, and then we will be doing all these things practically. So we'll start the class with the agenda. The agenda is overview of Spark, install Spark, configure PySpark cell, read data from a local file, read data from S3 file, select in DataFrame, filter in DataFrame, add and drop columns in DataFrame. So we'll talk about Spark first, and then we'll talk about what exactly the DataFrame is and how to analyze the data with the help of DataFrames. So Spark is a distributed data processing technology. So when you have large amount of data and you want to analyze that, you want to process that, if you plan to process that large amount of data over a single system, that would be like very time consuming, because nowadays billions and billions of GB of data is being produced every day. Like all the you can say your e-commerce website and all the IoT devices and many things are there, many devices are there which are generating data every single second. That means in order to process the large amount of data, we have to think something which is distributed in nature. Just like, for example, if I give you one example, suppose there is a school and there is a I would say one teacher there, and there are 20 students. Now we have to check the answer sheets of all 20 students. Now if only one teacher will start doing that, he can do that. Checking the answer sheet for 20 students is not a big deal, he can do. But suppose on the other side we have a big university which has like thousands of students. In that case, if you will allocate that checking of answer sheet of thousands of students to a single teacher, that's not a good idea. In that case, what you can do is you can assign that big task among multiple teachers. Multiple teachers can contribute to that. Similar way, when you have large amount of data, instead of overloading a single system, you can distribute the task among multiple machines, and those multiple machines will be parallelly processing your data. This is known as distributed processing of data. Few years back, around I would say around 10 years back, a technology came like Hadoop. Hadoop was able to deal with data on a parallel manner, on a distributed fashion. But the challenge was it was reading and writing the data again and again on the disk, which was making it little slow. So to overcome that limitation, the next generation data processing technology is Spark. As you can see, the second point, it is in-memory computation. That means it does not read and write the data again and again, because that is like you can say making your process slower. So it will load the data into the memory once, and then whatever multiple operation you are performing, all these will be happening in memory, which is making it more faster. That's why now people are migrating their jobs, migrating their projects from Hadoop to Spark. Another benefit is fault tolerance. Fault tolerance means when you are assigning some task on among multiple machines, right? And unfortunately, suppose any single task fails on one system. In that case, Spark is capable of assigning the task to another system. For example, if I go back to that school example, right? Suppose out of 10 teachers, one teacher is not available today. He or she is not feeling well. Does it mean that the task will not be completed? No, it's not like that. The same task we can assign to some other teacher. So it may be like taking little extra time, because earlier some task was supposed to be completed by 10 teachers, but now only 9 teachers are available. So they may take little extra time, but your task will still be completed. Same thing is in Spark. So it is very fault tolerant and there is no user intervention. It is capable of assigning that task to some alternate system which is up and running, and finally completing your data processing. So that's another benefit of Spark. After that, support multiple languages as per your preference. Whichever programming background you are coming from, you can write your Spark program in that language. You can use Java, you can use R language, you can even use Scala, and you can even use Python. The most common is Python, and when you write the Spark data processing job in Python, we call it as PySpark. Support SQL type syntax with Spark SQL. Once we will do the things practically, I will explain you like you can write your program in a programming language manner, and you can even write like a SQL type syntax, like stack star from table, where this condition, and group by, order by, joining with other tables and all that stuff. You can do all these things easily with the text file. Don't think that it's a database. I mean, this is very important concept. You may be thinking that we are using SQL type syntax, so what's new in that? You usually use SQL type syntax with databases, where you have tables, where you have you can say different columns and all this thing. But Spark can process your data directly from the file. You don't need to load that file into some database or into some table. That's not required. So how exactly these things will work, once we will do practically, then we'll explain. And the next is integrated with Hadoop, which is used to process the data parallelly on multiple machines. As I explained, right? This technology came few years back, and then due to some limitation, the industry is moving from Hadoop towards Spark. So this is very brief about what Spark is all about. Now we'll be installing it, and we'll be doing a few things practically, which will make your concept even more clear. So before we jump to installation part, in case you are having any doubt till now, you can ask me. Any doubt from your side, Fortune?
Neeraj, I have one doubt. Does Python support in-memory computation?
Not exactly Python, but Spark. Okay, I will tell you. So we will write the program into Python, but ultimately, who is the data processing unit? Spark will be processing your data parallelly on multiple machines. Python is just a way to give instructions or design your job, which you can design even in Java or even in Scala. And finally, once you submit your job to Spark, it's Spark's responsibility to analyze your data, to do the in-memory computation, and all the operations it will be performing.
Okay, got it.
So if you compare with Hadoop, because why I'm comparing again and again with Hadoop is because Hadoop is also used for distributed processing of data. And from Hadoop, now the industry is moving towards Spark. But if I talk about Python, that is a like just a programming language. You can even write in Java. You can even use Scala. And if I talk about myself, from last 10 years, I have worked on Hadoop when we were writing the data processing job in Java. And then we moved to Spark and we were writing the program in Scala. I remember those days around 4 years back. But in the current scenario, most of the companies, most of the developer, you will find they are writing the program in Python, because Python is very extensive language and very simple to use, and very less number of code you can write, lines of code you can write, and then Spark will be actually analyzing and processing your data.
So normally, Neeraj, like in our daily basis, the data engineering guys, like how they process their job. What I meant to say is, suppose I've written a job in Python and we are deploying
Mm.
it on a Docker container. So who is processing it? Is it Docker who is processing those jobs, or
Okay, I will tell you. So Docker is nothing but just an operating system or an environment where you can execute your jobs. Now you have a Python program, whether you run your Python program on Lambda, that's also a small, or you can say a temporary server only, because behind the scene AWS will launch one server for a few seconds. It will execute your Python code and then it will terminate the server. Or you deploy your Python code on EC2. That means same, like you are running your Python code on the server. And similarly on Docker container. Docker container is also nothing but a, you can say, an isolated containerized environment where you can execute your things. Now coming to your question, right? Python can process your data even without Spark. But what's the difference? The difference is Python is not capable of distributing your job on multiple machines or tracking the progress of the job on multiple machines. And in case out of multiple machines, suppose one machine fails, who will detect that? And how automatically the task will be reassigned to alternate system? All these things are taken care by Spark. So usually when you are dealing with a large amount of data, then you should think about Spark. If you are simply processing very MB of data or something like that, then you don't exactly need Spark. You can write your logic in Python itself. You can read the file in Python and you can execute that. So there are many ways to process your data, as we discussed earlier as well. Like you can load your data into this one S3, and on top of that you can create Athena tables, and then Athena tables will behave like a database. You can do select star from table and everything you can do. So that's one way. Redshift is also like another RDBMS service from AWS where you can analyze your data. And this one, Spark, is another data distributed data processing technology. This is mainly when you are dealing directly with the text file and there is no concept of database and all that stuff. You can directly load your file into DataFrame and then you can perform your processing over there. So we'll do it practically and then it would be more clear.
so like Neeraj, last out, in the Spark, like as you mentioned, it distributed the process. So like if we are processing millions of rows of data, so it
Mhm.
basically distribute those millions of rows into thousands in each process, and then
Yes.
it processes it manually. That's what.
Absolutely. Because if it's not doing parallelly, then there is no point of distribution, right? Because only benefit is that multiple machines can contribute to that. And then multiple machines will process your small part of data. And then Spark will be combining the output also, because multiple machine will be generating small set of output. Then someone has to consolidate that as well. So all these different operations are, if you have heard about a map reduce term, so map is something which is happening on individual slave system. We call it as master slave architecture. So slave system will be processing your data on multiple machines, and then master machine will be like combining that small output to create the bigger output. And all these things are like completely transparent to the user. You don't exactly have to worry about like how many machines it will be contributing. I mean, it will be distributing my task among, and who will be combining the output. And in between, some machines, few machines went down, and then master machine had to reassign the task to some alternate slave system. All these things are completely taken care by Spark. As a user, as a developer, we will simply write our Python code, and that's all. We will analyze our data.
Yep, I
Does that
understood.
answer the question?
Ye- Yes, Neeraj.
Okay, that's good. So we are in very initial stage. Let's install it. Let's take some data. I will create data frame. I will show you how exactly it's working. Okay, so how to download Spark? There are many ways to do it. You can simply go to Google and simply do like download Spark. I can show you that. Okay, so you can do download Spark on for Linux, right? So you can go to here, spark.apache.org. Spark is an open source data processing technology from Apache, and it's free of cost available. You can go there, and then as per your operating system, you can install it or you can download it. So this one is the tar file. You can see spark hyphen some version hyphen hadoop 3.2.tar.zz. This is the distribution of Spark which comes along with Hadoop. Okay, so you can either download it directly. What I have done is, because I will be doing all the things practically on my Cloud9, what I did is I have used wget command. So I will show you. Wget is nothing but like downloading with help of a command, not from the browser. So you can have a look at this command. I will just type wget and then the complete link of that file, whatever file I was showing that. I just double click, right click on there, copy the link, and I did wget. What it will do is it will download a tar file. Tar is a compressed file. You can see here spark hyphen 3.2.1 hyphen bin hyphen hadoop 3.2.tar.zz. This is a compressed file which will be downloaded on your Cloud9 or whatever system you use. You can use on Windows, you can use on your Mac or wherever. Once your tar file is downloaded, the next thing is untar it, extract the content of tar file. So you can do that with the help of a command. You can see here tar xvf. These are different arguments like x for extract and v for verbose. It will display like what exactly it's extracting. You can even skip v, that's fine, absolutely fine. So tar and then xvf and then your complete your file, whatever your file name, right, that you can provide, and it will be extracting into the directory. So let me go to my Cloud9. Okay, let me see where exactly I am in. I am into this directory, and you can see here the last one, the red one, right? Spark hyphen 3.2.1 bin hadoop 3.2.tar.zz. That was my compressed file, and then I uncompressed it, and it became this one. This was extracted inside a folder. If you want to go inside that folder, there will be many more things which we really are not required to know. You can see that there is a bin folder, there's a conf folder which contains some configuration. There are a few examples. There are some jar files, Kubernetes related things. There is licensing and some Python related example, R related things, and many more stuff. Right? You don't exactly need to go inside that. That is just your installation stuff. Now, how to use PySpark? So in order to use PySpark, first of all, we need to open PySpark shell. And what exactly PySpark shell is? Just like your current shell, right? This is my just Linux shell. It is recognizing only Linux command. Like if I type pwd, it will display my present working directory. You see that? If I type who am I, it will display the username. The username is nothing but ec2-user. That's the default username. So you can see that ec2-user. If I type date, it will display the current date and time. You can see here. So this is my basic Linux terminal. But in order to execute Spark command, or I would say PySpark command, you need to open the PySpark shell first. How to do that? I will show you one slide. So this one, okay. So in case you are planning to play with only local files, that means there is some local file in your Cloud9, and you just want to play around it, then these two things are not required. AWS access key and AWS secret access key. These two things are not required. If you remember, let me remind you, when we talked about IAM concept of AWS, we also talked about how to create a user. So when you are creating a user, you can provide some username, you can provide some password from your side, or even you can AWS can generate some random password for you. At the same time, it gives you the flexibility to generate the access key ID and secret access key. These things are used for development purpose. That means whenever you will try to connect to any AWS service, suppose you are writing a Python program, and from there you want to connect to S3 file. You want to read S3 file, or you want to write something into S3. In that case, for the connection, for the connectivity, you need to provide these two things, because we cannot blindly allow people to connect to my S3, right? they can misuse it, or they can delete my data or something like that. So this is very important, these two things. And on my system, I have already downloaded that Excel sheet. Whenever we create a IAM user, it allows you to check a box like create the secret key and access key, and then you can save it somewhere. So for security purpose, I have kept it like star and star, just for taking a screenshot point of view. Otherwise, you have to provide the actual access key and actual secret access key. You have to define these two variables. Okay, so today we'll not be doing this. Today we will be playing around with local files. Maybe tomorrow I will show this part. Okay, after that you can see this one, /PySpark. That is your command to start the PySpark cell. And along with that, you can, if you are planning to connect to AWS services like S3 or any other service, right, then you can specify this additional argument --package org.apache.hadoop /hadoop -aws whatever is version and all. Okay, once you do this, your Spark cell will be opening. As you can see here, it is saying welcome to Spark. Version is this one. There are two more things. One is known as Spark context, which is available like SC. And how to use that, I will show you that shortly. And Spark session is available as Spark. Basically, when you are opening a Spark cell, it makes few things already ready. That means it will create a connection to Spark running framework, Spark job execution framework. And you can directly use those variables like SC and Spark. So when we will read the data, when we will write the data, these variables will be used. Okay, so let me open Spark cell quickly, and then we will start doing something practically, because theoretical explanation will be a little boring. Let's do something practical. So I will type PySpark. Okay, so I'm typing PySpark, and along with that I'm doing package and that information. It will display few details because it is starting the Spark engine behind the scene, and then it will start our Spark cell. So Spark cell is separate from your Linux cell. The difference is that Spark cell will recognize only Spark commands. If you type pwd, if you do date command and all this thing, it will not recognize. Shall we try pwd? No, it does not understand. You see that it is saying pwd is not defined. Shall I try date command? It's not even identifying that. So Spark cell is specific for Spark commands. Okay, before we start analyzing any data, in case you are having any doubt till now, you can ask me. Okay, so before we start analyzing the data, I will show you some sample data first, because we need to understand what type of data we have, and accordingly we will start doing the practice. I have written few programs over the weekend for you. Just give me a moment. Close other tabs. So on the left side, you can see there are a few programs written. Add and drop column in DataFrame, filter in DataFrame, group by, join, PySpark example, and many more, right? We will be doing all these things practically, as well as I will upload all these programs into my Google Drive so that you guys can access it and do some practice. So let me show you the file first. Sample employee data.csv. I'm showing this one. Let me increase the font size so that it is easy for you to have a look. Okay, is it visible now?
Yes, Neeraj, it's visible.
Okay, thank you. So this is sample data. For our learning purpose, I have created that. The very first line is header, and that's completely optional. If you don't, if your file does not have a header, in that case you have to provide the header separately. That would be little like tricky. I won't say tricky, but usually if your file has a header, that's very good, because Spark is capable of reading the first line as a header if you specify. If you say that my file first line is a header, then your Spark will consider first line as a header only. It does not consider that line as a data. So in this case, employee ID, comma, name, then the next column is age, after that gender, after that department ID, and the last column is manager employee ID, who is the manager for that particular employee. Usually in real-time scenario, you have very big file containing millions of rows and hundreds of columns and all that stuff. But for learning point of view, I don't think we need those many rows and those many columns. I think we are good with this data. So you see that there are few rows are there. Employee ID EMP001. Then the name is Neeraj. Age is 32. Gender is male. Department ID. We are not talking about department name. As of now, we only have department ID. Maybe tomorrow when we talk about how to join this data frame with other data frame, then this department ID we will be using. And finally, manager employee ID. So employee 007 is my manager. Similarly, the next row, we have the next name Sahil, Fortune, Srikant, Vidya, Lakshmi, Mahesh, and all. Okay, this is my sample data. Now we will create a data frame from this file. You may be thinking what exactly data frame is, because data frame word I'm using more frequently. So data frame is you can say it's a virtual table. We cannot say real table because we really don't have any database. First of all, we really do not have any table, because in database you create a table first, right? And you define some set of columns, and you also define some data types. That employee ID should be numeric, name should be alphabetical, age should be a number, something like that, right? And while inserting the data, you have to follow the data type very strictly. If you have declared age as a number, but while inserting the data you are providing ABC into age, it will fail. It will not accept your data. On the other side, on the Spark side, your data is not dependent on table. Instead, it's reverse. You already have some data. You already have some header. You already have some data type also. You have to create a virtual table on top of that. So what Spark will do, Spark will load this data into the memory. That's why we call it as in-memory computation. And that will behave like a table. You can do some processing over it. You want to filter something, you want to add something, you want to remove some column, or I would say you want to do some grouping or some aggregation and all that you can do. And finally, whatever is your output, you want to store that output back into some output file, you can do that. So it was behaving like a table only temporarily once it was in memory, only till that time. Ultimately, it was a file, text file, that can be comma separated, tab separated, or any other delimiter. That's completely fine. So you read the file, you process the data, and you write the data output back into the file. Okay, let's open our console and we'll be doing this thing practically. So I will be opening my Spark cell. Let me split this window into two parts so that we can do something practically. This one would be better. Okay. Okay, so I will show you a few things. These are a few functions I am importing from PySpark.sql.function import star. So there are many functions, like you want to do count, you want to do min, max, average, this one, that one. There are few functions which you can import. For today's class, it's not required. You can ignore these 3 lines, not required today. Tomorrow we will be doing that. Okay, let's move to the next line. What is the next line? Let me decrease the font size. Okay. Okay, so I'm defining a variable emp file path, and I'm giving my complete path because today I'm dealing with local file. So what you can do is there is an option here. You can go to file, and there is an option of upload local file. So the file which I will provide to you, you can download from Google Drive on your local system first, and from your local you can upload into your Cloud9. So now this file sample underscore emp underscore data.txt is available on my cloud9. So I will use this file. So I'm giving the complete path. As you can see, /home, the username, environment, PySpark code. That's the folder I have created. Inside that, sample_emp.data.csv. I'm just declaring a variable. The next is empdf. Df is stand for data frame. Although you can give any name, but just to make it meaningful, I am giving employee data frame is equal to Spark. You remember when we opened Spark cell? Let me show you. It was saying something, Spark session is available as Spark. I'm using that. Spark is nothing but a connection to your Spark engine, because ultimately Spark has to process your data, right? So what we are doing is we are doing Spark dot read dot csv. If you have a CSV file, you can use this one, spark.read.csv, and then you have to provide the path, the very first and the mandatory argument. After that, there are two additional arguments which are like optional. One is header is equal to true. You have to specify whether your file contains the header or not, whether the first line is your data itself or first line is a header. So I'm saying header is equal to true. Now Spark will consider your first line as a header. It will treat that as a column names. And then infer schema is equal to true. What is that? Infer schema means by looking at the data of your file, it will automatically choose some data type. We don't have to declare that. I will not tell Spark that age is a number and name is a alphanumeric, or I will not do that. Spark is smart enough that it will analyze your data and it will automatically decide that, okay, this age is containing all numbers, so it will declare the data type as integer or number or something like that. If you're using some float value, suppose some amount 2.50, 3.75, something, it will automatically take the data type for that. That means infer schema. So I'm making that as true. I'm trusting that let Spark decide about my data type. Okay, this is how to create a data frame. And the next is empdf.show. It will display. It's like you can correlate with select star from table. It will do whatever is there in your file. It will display that as a tabular format. Let's try that. So I will copy the first line, this one. We'll go line by line so that you can understand. Control C, and we'll go to our Spark cell, which recognize only Spark commands. So there's a shortcut Control L, which will clear your screen quickly. And then let's paste that. Oh, it will not work. Why? Because I have to provide this path also. So I will execute these two commands. Okay, so you can see this one. And now the next we have to do is, let me copy the next one, df.show, this one, employee df.show, Control C. Enter. And you see that it is displaying the data in a tabular format. But as I explained, right, it's not a real table. The data is loaded into the memory and it is behaving like a temporary table for your processing needs. Once you are done, you can write your output back into your text file. You see that now. It is displaying in a very beautiful manner, like columns are displayed separately, right? Employee ID, name, age, gender, department ID, manager employee ID, which is taken completely from your file only. And then you can see other details like all the employee IDs are there, names are there, and complete data is there. There is one more thing. If you want to check the schema means your data frame definition. If you compare with the table, then table has columns and their data type. Similarly, data frame has also columns and their data type, which we call it as schema. So what you do is you do emp_df dot print schema. Print, S is capital, SCHEMA, print schema, and opening and closing bracket, enter. And you see now the first one is employee ID, that is string. It automatically understood because you have EMP001. So there is a string also and number also. So ultimately it will take as a string. Second one is name, that's also string. Age is an integer. It's completely a numeric value. There is no alphabets there. So it has considered that as integer. The next is gender, that is your string, department ID string, manager employee ID is for the string. This is the schema automatically, I can say, inferred from your data. So this is very, very brief, very initial concept, like how to read the data, I mean, read a text file into a data frame, and then how you can print the schema for the data frame and how you can print the data. One more thing is this emp_df.show, it does not display the complete data. As of now, we have only 7 rows, so it's fine. It's displaying complete. Otherwise, the standard is it will display the 20 lines from your data, because usually we use Spark for dealing with large amount of data, millions of rows, and no one is interested to display millions of rows over the terminal. Does not make any sense, right? So df, whatever your data frame name, dot show will display the only 20 rows. But if you want to display more, or if you want to display less, you can provide the number in the bracket. Let me show you. What I will do is I will do employee_df.show and I will say 5. I just want to see 5 rows. And now you can see that it is displaying only 5. So this is very handy when you are dealing with a large amount of data, but for analysis purpose or for development purpose, you want to deal with small set of data, then you can use this command. Okay, before we proceed to the next one, you can ask me in case you have any doubt.
The syntax are similar, I think, right? It's
Similar to
just
what?
similar to Python, like instead of underscore, we just do dot.
No, it's Python only. We are writing the program in Python only. Okay,
Yeah,
I got
no,
your point. So you are saying that instead of directly processing the data in Python, we are using Spark and concept is same.
yeah, the concept is same, but the syntax are a little different.
Syntax is little different. Another difference which I was explaining to Sahil is that Python is not capable of processing your large amount of data on multiple systems.
Yeah,
So
this is
if you are dealing
distributed.
with seven lines of code, that's fine. You can deal with simple Python. Don't even worry about Spark and data frame concept. But when you are dealing with large amount of data, Spark will help you to distribute your data and your processing among multiple systems. Right now, for learning point of view, we are doing only on a Cloud9. But usually Spark can be installed on multiple systems, suppose 20 systems. Out of those 20, one will be working as a master and remaining 19 will be working as a slave. So you will write your Python program, or I would say PySpark program, and you will submit that PySpark program to master machine. After that, it's master machine's duty to assign that task or to distribute that big task among multiple slaves to process a large amount of data in less amount of time. That's the concept of Spark.
Got it. So basically, like node, right? When you say distributed system.
Node, absolutely. We call it as node. So we
Yeah.
call it as master node and slave node.
Yeah. All right.
Okay, that's good. If you guys want, right, I have some Hadoop videos as well. A few years back, I was conducting that Hadoop training, not right now. Right now, no one is learning Hadoop. But if you want to just get a quick idea what Hadoop is all about, you can go to my YouTube channel, as you are already every day looking at the recordings, right? There you will find Hadoop related videos as well, which you can watch in your free time to get some idea if you want.
Sure.
Okay,
Thank you.
yeah, welcome. Let's move to the next slide. Let's see what is next. So we talked about read from local file and read from S3 file also. So there is no much difference. Only thing is, instead of local file path, you will provide a S3 file path. So we can try that today itself. Give me a moment. I will show you that. Okay. So first of all, I have to set those access key and all, otherwise it will not work. So I will do Control D. Control D is used to come out of Spark Cell. I will do Control D and I'm back. If I do pwd, you can see that it's working fine. Date commands are working fine and all that. I need to set those variables. Let me quickly do that. I did yesterday, so I think it should be somewhere. It's there. So this one is access key ID, and then I will do the another one. Just give me a moment. I am stopping the screen sharing just for a minute. I will tell you why I stopped the screen sharing. Because your access key and your secret access key are very, very sensitive information. If it is disclosed to the entire world, because if I will upload this video on YouTube, right? If anyone can copy my access key ID, you can be in big trouble, because those people can use your access key and Spark key for their purpose. Like they can upload some large amount of data, or they can launch lot many EC2 instances on your account, and your credit card will be charged for that. Okay, so just for your safer side, just for a tip, you never expose your access key and all this. I'm just doing it. Just give me where it went. Okay, I'm resuming my screen sharing. Just give me a moment. Okay, so I have set those two variables now. I have set like access key and secret key as I explained. And now what I will do is we are ready for reading from S3. So let me see, I should have some file. It's here. Okay, so you see that there is no much difference. The only thing is S3 file path. So S3A, whenever you are doing programmatic access, reading or writing, you have to provide S3A, that's the standard, and then you will provide the complete path, my bucket name and my file name. So whatever file I was dealing with on local Cloud9, the same file I have uploaded into my S3 bucket as well, nothing new. And then the same way we will just load the data, I mean read the data. Spark.read.format, CSV format is there. If it's a JSON, you can do a JSON as well. Load S3 file path, header is equal to true, infer schema is true, and then we will do the print schema, and then we will do the show. Let's do it quickly. I will quickly execute all the commands together. I will copy all four, Control C, and where is my cell? Here, Control V. Okay, it's not working. Why? Because I'm not into Spark cell. Give me a moment. Okay, I was in my Linux cell, and that's why it was failing. It is saying S3 file path command not found and all. It's okay. We'll be opening Spark cell, and then we are ready to execute the commands. So setting up those environment variables, right? Access key and secret access key, you have to do outside of Spark cell in your normal Linux cell, not in the Spark cell, because those are environment variables. So I set the environment variable, and now I'm opening my Spark cell, and after that I should be able to execute my Spark commands. So let's quickly paste. So you notice that when it's reading from S3, it will take little time, because when it was reading from local, it was very fast. Now it will create a connection to S3, and it will take little time. Okay, so you see that I'm displaying print schema, it's displaying that, and finally we'll do dot show with 5 rows, and it should display. Yeah, it's working fine. So for a developer, it does not make much difference. You can read from S3, you can read from local, and it's completely. Maybe usually we do the development purpose with local data, so that we can write our queries, we can validate our output and everything. Once you are done with your development, once your code is ready, you can definitely read from S3, you can analyze it, you can do whatever you want. And finally, when your output is ready, you want to write it back into your local or back into S3, that also you can do. Okay, so let's go to the next slide. Let me see what is next. Select in DataFrame. Just like in SQL, we do select first name from this table. You can do the same. Syntax is a little different. And after that, filter command is also there. You can do that as well. Let me quickly show you that. So we'll do select. So what I will do is I will create one more data frame, or you can even use the same. It's up to you. Usually, if you are making some modification, we can use some other name. So emp underscore new underscore df. I'm just giving some new name. Okay, emp underscore df dot select. In the bracket, provide your column names, whatever you want, comma separated. I will take only two, name and age. Okay, and enter. empdf is not defined. Okay, I think we use some different name. Just give me a moment. Why we are using sales df? emp. Control C. Okay, so new df is equal to employee s3 df. Just playing around with different names. Okay, this one. So what it did is your employee s3 df, this was containing complete data, all rows, all columns. But here in this employee new data frame, I have selected only name and age. You want to verify? emp underscore new underscore df dot show. You see that only name and age. This is like filtering the column because I selected only two columns out of multiple columns. You may be interested to do some filtering for the row, right? We can do that as well. I will give employee underscore new df. This time I will do filter, not select. Filter is like filtering the rows, like where condition. So I will do filter. In the bracket, you provide some condition, like you have to give call. Call stand for colon. I will explain what does that mean. Call stand for colon and provide some, suppose, gender. Okay, is equal to, because for comparison we use double is equal to, and what we will do, suppose we will give female. Okay, and enter. Call is not defined. I know why it's behaving like that. I told you, right, there are few import statements. This one, call is a function, so we need to import this. We'll do that quickly, should not take much time. Okay, and now let's try that again. You see now, so employee new df is equal to employee s3 df dot filter, gender is equal to female. Now let's display this, and you should find only female details, I mean female candidates details. Employee new df dot show. You can see that. Fortune and Lakshmi and all other details, right? So this is way like how you can do select, how how you can do filter, and there are many more things which we will be doing. Let me check. Okay, before we jump to the next slide, if you have any question, any doubt, you can ask me. Okay, seems like there is no doubts. Let's move to the next slide. Add and drop column in data frame. You can add additional columns as well, and drop also you can do. So sometimes suppose out of 10 column, you want to select 9, but you have to provide 9 column name, right? That can be tricky. I mean, tricky in the sense like time consuming. Or there can be 100 of columns and you just need 95 out of that. So you need to provide 95 column names, which is not a good idea. You can do the reverse manner. Instead of providing 95 names, let's drop the 5 columns. So you can do drop, and you can add columns as well. Let's quickly show you. So we will play around the main df, this one, employee 3 df, right? We'll play around with that. So emp s3 df dot with column. With column is like for adding a new column, column. Notice that C is capital. s3 df dot with column, that means whatever are the existing column, I want to add one more column on top of that. Provide a column name, whatever you want. I will give double age. Okay, what should be the value for this? Either you provide some hard coded, which I don't want. I want to just double of the existing age, right? So we'll do column call and provide the column name is, right? Is multiply by 2 star 2 bracket closed. To make it more meaningful, you can even put this value into a bracket so that no confusion, right? So column A is multiplied by the 2 that I have put into a bracket. So basically what it will do is, along with your existing column, it will add one more column with this name and with this value. Let's check it out. But I didn't assign it to any some new df, right? Okay. Any name you can give, any new df whatsoever. New df dot show. Enter. You see that the last column, the original age was 32 and the double is 64, 28, 56, 22, 44, like this one. This is only one example. You can use anything. And it's not always required to assign to a new data frame. I was showing you so that when you are doing the coding, it's more meaningful that, okay, this is my initial data frame, then I added something, then I removed something, then I did some aggregation, then I did some grouping. So it would be more readable. Otherwise, you can even assign to the same one. Let me show you. So instead of new df, I can assign to the same like emp s3df, emp s3df. So you can do that. One more thing, if you don't want to assign and directly want to show, you can do that also. Like let me add one more column. Okay, I will make it triple A's and will multiply by 3, and I can directly do show here, dot show. That's all. I'm not assigning to anything, simply doing directly show here. You see now we have all the original columns whatever we had, and there is a double A's and there's a triple A's, but this is not assigned to anything. So usually we keep on assigning to some different data frames so that we have a track like, okay, this data frame has these many columns, we are doing filtering, we are doing grouping, we are doing some aggregation, we are joining with some other data frame and all that stuff. Okay, so friends, that's all about today's class. I hope you got some basic idea about PySpark. Tomorrow we'll be talking about more concepts like grouping, joining, window functions. All these things we will be exploring in tomorrow's class. With this class, we are done for the day. So in case you have any doubt, you can ask me.
No doubts. Thank you, Neeraj.